All right, let's dig into values and types. All right. So what we're going to talk about right now is what is a value in programming, then what is a type, and we'll study the type of operator, and then we'll talk about the different types that JavaScript have. We'll only talk about a few today, just to get our feet wet, and we'll go over plenty of examples. Cool. So what is a value? Well, software that we write stores, retrieves, and manipulates values, right? That's our whole job as programmers, is to, take values in from people, manipulate them, and then possibly show them, for example, like price of a stuff in a cart, etc. So for example, the number 5 is an example of a value, right? This is something called a string. So the string apples is also a value, right? 6 characters, APPLES, that's also a value that JavaScript understands. So what do we mean when we say 5 is a value? Well, for example, if I console log, quote 5 is colon, and then comma 5, if I console log apples, apples colon apples, what I expect is saying something like this. 5 is 5, and apples is apples, right? So these are things that JavaScript understands and is able to output and show to the user. Now, values have certain set of properties about data, but one thing they have is that they have this something called a type, right? So a type describes the intrinsic and extrinsic properties of a value that are shared across all values of that type. So, for example, type of 5 is a number. So, and the type of apples is a string. And what values that have the same type are is that they share similar behaviors across all values of that type. So, for example, strings can be uppercase and from like apples to apples, and all strings can have this property. But for example, numbers, it doesn't really make sense to uppercase numbers, right? So like uppercasing 5 doesn't make any sense. So numbers, the type of numbers don't have the ability to be uppercased. So JavaScript, provides you a handy operator for you to see what a type is of a value. So you can do type of 5, and if you console log that out, or if you console log out type of values, or type of apples, you get something here like, console log type of 5, you get number, and type of quote-unquote apples is a string. So what type of does is whatever value is after it, it will output the type that JavaScript interprets that value as.
And one small thing to note is the output of the type of operator is a string itself.
Yeah.
Always.
So what type of returns, is a string. So for example, if I do type of 5, what do you expect to get?
I would say string.
You would say string, right? Because what's happening here is that the type of on the right is first interpreting that 5 and say, okay, what are you? And then it's returning the string number. And then the second type of on the left is saying, okay, type of number in the string is a string itself.
Right.
So, for example, some more examples. If I do type of 5 or type of 2.55 or type of negative 1,000, I expect to get number for all of these. Now, one aside that's interesting is that in some languages that you might have studied, you have to be careful whether you're talking about numbers that do or do not have a decimal point. So here, 2.55 and 5 would be different types in some languages. So, for example, in Java or in C, they would consider 5 an integer type and 2.55 a floating point type. I won't get too many details about floating points versus integers, but basically understand that floating points can support decimals, things after the decimal.
In JavaScript, however, like each of these three are considered numbers.
Yeah, so JavaScript doesn't have the idea of ints and floats, it only has the idea of a number. So basic arithmetic, here we can see things like 10 plus 5, 10 minus 5, 10 times 5. These operators, the plus, minus, multiply, divide, all work on number types, right? So this we get back kind of the things that we expect from mathematic operators, right? We would get back 15, 5, 50, and 2. Look at this operator, this is called the modulus operator, the percent sign. What it does, it divides two numbers, the two numbers around it, and returns the remainder of those two numbers. So for example here, what would you expect if we do 10 modulus 5, right?
I would expect 0.
0, right? Because what you do is you say 10 divided by 5 is 2, and there's no remainder, right? And so we get 0. 11 modulus 5, what would we expect? Same thing, 11 divided by 5 is, numerically is 2.2, right? But then we have that one remainder, so what modulus will return us is 1. And we see that here, 0 and 1. Next, we'll talk about comparing numbers. So for comparing numbers, we want to use the strictly equals operator, which is denoted with 3 equal signs to compare numbers. So for example, here, we do console log 10 equals 10, or we can do console log 10 equals 11. Now the curious thing here is that, what is this equal operators returning, right? So whereas 10 times 10 would return, that's a number operating on a number, returns a new type of type number, right? Whereas here, this is a number, the operator being the strictly equals and number, and these two types in the operation don't return a number, they return what we call a Boolean value, right? So
Right.
Boolean means true or false. So the question is, this operator is saying, is what's on my left and what's on my right true, right? So comparing these two number types, it's saying yes, it's going to return true or false, and then here we see 10 equals 10 and 10 equals 11. 10 does not equal 11, so we get a false. You can use the does not equal to compare numbers as well. So, here we would get the inverse of what we just got, right? 10 does not equal 10 is false, and 10 does not equal 11 is true, right? So this is the opposite of what we just got. So you think that triple equals is these two things being the same, and bang equal equal or exclamation equal equal is, are these two things different? If they're different, I return true, and if they're the same, I return false.
Right.
More operators we can do to compare numbers. We can use the less than equal to, greater than equal sign. They work just like you would expect to in math. So here we have all 4 variations of 9 and 10, and which one would we expect to return true, which would we expect to return false?
Well, I guess the first one is true. 9 is less than 10. Second one, 9 is not greater than 10, so that would be false. The third one is 9 is less than or equal to 10. That would also be true. And then the next one would be false. So
Yeah.
I'm going for true, false, true, false.
Exactly. So again, the key thing to pay attention to is that these operators work on two types, or work on, they take in 2 numbers on one on each side. Both of these are numbers, but what it returns is a different type, right?
Right.
It returns a Boolean type instead of a number type.
Right.
So the Boolean type, only 2 values have the Boolean type, the value true and the value false. So we do a type of on this, we return Boolean and Boolean. Now, quick quiz. What, the Boolean that this console log is outputting, what type is that?
So that itself is a string, right?
Exactly.
If I
Like
remember
we just,
correctly, yeah.
which I talked about, this type of true, you can think of type of as an operator that takes a type and returns a string representation of that type. Sorry,
Right.
type of takes a value and returns a string representation of the
that value's type.
of that value's type.
Right.
Right. So the question is, why do we have types at all? And really, it's both for the developer and for the JavaScript engine itself, right? Because
Right.
as we're programming and we're thinking about the different types of things that we can do, we want to store different kinds of values. And sometimes we want to store values that can have things like 2 uppercase, give me the length, combine these 2 strings. But we don't want to say, is this a string added to a number? We want to make sure that we're not doing that kind of stuff. And so knowing the types of it can be very helpful. And then for the JavaScript interpreter itself, knowing the types of these things is also helpful for it, so that it knows what kind of different things it can do for it. So if it gets an instruction from a programmer to say, hey, tell me the length of a Boolean type, it's going to say, it's going to either give you a weird value or throw an error and say, hey, that's not something that this type supports. And next we'll talk about a type that we'll be using a lot in this program, which is creating the string type. So we can create strings with single quotes or with double quotes. So both of these should return string. There's a little bit difference between those two, but it's not too much to worry about right now. But both of those are string types. And the word string just comes from it's a long history in computer science. The idea of, first there were characters, and a character is just one character of the alphabet, like the letter H, letter A. And then over time, you string these together to create, what we think of as either words, sentences, paragraphs, or, a string can be arbitrarily long. But we call these strings now to represent kind of, contiguous characters. So strings have, strings are a type, And they're a type that's pretty much been universal in almost all programming languages since, I would say, since C.
Yeah.
So strings, for example, we can access a character inside of a string. So strings are, as I said, a string of characters. You can think of a character as a Christmas light, then the string is the whole light strand itself, right, connected one by one. We can access a particular character using something called the bracket notation. So for example, if we want to access the first character of a string, we start with the index of 0. And this is something to just continue to watch out for, that we will constantly see things in programming start at 0. So we're going to start counting at 0. So for example, if we do console log happy of 0, console log happy of bracket 1, what we'll get is on line 5, we'll get H, and on line 6, we'll get A. So 0 being the H character, and 1 being the A character. Now, let's see. So if we do 2, 3, 4, now you see like console log happy bracket 4 is going to return you Y. And so oftentimes you'll see things like, give me all the characters in this up to the length minus 1, because length minus 1 represents the last thing of a string, because of the way we count at 0.
The last character is at index 4, but the total number of characters are 5. So dot length returns 5.
Yeah.
But the last character is at index 4.
So it's talking about that. Most all strings have this dot length property. So we could do happy dot length, and then what this will return to us is 5, as Nimit just mentioned. So 5 characters, but if you want to get the last one, you do 5 minus 1 to get the 4th indexed character. Now, here's what's interesting, right? We talked about some of the operators in math, like 10 plus 5, and it does kind of what we expect it to do, right? Just based off our basic intuition around math. But of course, these operators can also mean different things based off of different types.
Right.
So here we'll talk about an operator, we'll talk about string concatenation. So concatenation is kind of a weird word. Really, it just means joining two things together, right? Taking one thing and adding it to the other, to another thing. So here in JavaScript, it uses the plus operator to represent this thing too, right? So here we have happy plus a string with a single space plus the string together, right? And this plus sign takes a string on the left, a string on the right, and it returns a new string. So the way we can read this is, hey, we have this plus one is going to say take this string and return a new string, and that string is going to be happy with a space at the end, and then take this happy with a space at the end and add it to together, and then we'll get something like happy together.
So David, I have a question for you. Earlier in some of the console log examples, I saw that we were using commas instead of pluses in console log. So can you tell me a little more about why?
So that's an interesting point. So console log is a very powerful function that we'll be using a lot, both to debug, to store messages, and to just really log things that our program is doing. Now what console log can do is it's a function that can take an arbitrary number of arguments, right? So for example, let me go find one here. If we, of course, and now that I need to find one, I cannot find one, but
these are all the math ones, I guess.
Yeah, so okay, what I will say is that when you put a comma together, what console log is doing is it's outputting each version of the arguments that's given. So if you console log, a string, comma, a number, comma, a string, what it's doing is, okay, I'm going to output the string, then I'm going to output a string version of that number. So it'll take a number like 10, the value 10, and convert it into the string that has a 1 and a 0 characters, and then I'll output the last string. So console log is implicitly concatenating the arguments it's given.
Right.
What this is doing is it's saying, hey, before you call console log, do these concatenation operations, and then call console log with just one argument, which is the string happy space together.
So the output of the both of them will actually look pretty similar, but like there's the people who are really kind of memory conscious, which we should also be, all be a little bit, often prefer to use the commas actually, just because we don't have to create this new concatenated string in memory before outputting.
And we can show a quick example here. So for example here, if I console log, So you can ignore this thing here. What all this thing does, it's actually really cool. This x1bc will clear the screen before outputs there. So
Nice.
let's console log happy space together. If I save that, you see here we're getting actually interesting 3 spaces because console log is actually inserting a space between each of these arguments. Now if I do this with the plus, you see when I save it, it actually outputs happy together. Now let's say we let's say we could actually dig inside this console log. What we would see is something like, we can actually do that here by doing something like console.log is, we'll replace a function and then, actually no, you know what, we'll get to that.
We'll get to that
We'll get to
later,
that
yeah.
that'll be a fun exercise for later.
Yeah.
Okay, so again here we're getting the string happy together, but we're first concatenating with this plus operator before we call console.log. All right, and just like with numbers, this triple equals and does not, bang equal equal also works with strings, right? And so here we can do console log same, and both of these are true because same is equal to same as a string, and same does not equal to different. And so this is an example of an operator that takes 2 string types and then returns a Boolean type, right? So again, operators don't have to necessarily return the type that they work on. They can convert it into a new type.
Right.
So here, a string is never strictly equal to a value from a different type. So for example, here, even though strings, even if the string looks like something, it will not be equal to that thing. It will not be strictly equal to that thing. So for example, here, the string true equal to true, this will always be false, right? Because even though the string true looks like true, it's not actually strictly equal to the value true itself. And here, same thing with the string of 10, the string value of 10 versus the number value of 10. So here, both of these are false. And we should take comfort in this because what this is saying is that when JavaScript is running these operators, it also, when it wants to see if something is strictly equal, it's also considering, are these things not only equal in the value they appear to us, but in the underlying type that the JavaScript interpreter is seeing.
Right.
So then let's go over something like different string methods, right? So one of the benefit of string types is that they come with all these methods that make it easier for us to work with them, right? So a method is really just an action, or you could think of it a function that can be performed on values, right? So all the different types have different built-in methods. We've already seen a lot of these with the operators, right? They're not necessarily traditionally we call them operators because they're kind of built into the language, but they act on different types in different ways, right?
Yeah,
So-
they're similar to methods or functions in the way that they function.
Yeah. So here, to call some of these methods, what we do is we take a value, we put a dot after it, and then we put the name of the method, and then we put arguments, if there are, passed to the method, right? So some string methods include things like toUpperCase, and so here we can do console log. We take a string, this is the string value, and then we put a period after it, and we call it toUpperCase. And you see we put these parentheses afterwards to say, call this function, right? Call this method. And we get so happy, right? Now, this toUpperCase wouldn't make sense on a number, so 10.toUpperCase doesn't mean anything.
Do anything, yeah.
Just one thing to remember. Now, what if we don't actually remember those parentheses at the end of toUpperCase, right? So what if we console log out this, right? As a beginner, people make this mistake constantly, right? So they forget to call the method. And granted, in some languages, they let you call a method in either case, right? So for example, if you're coming from Ruby or Python, this actually would call the method instead of just accessing the method. So here, what console log outputs is this function toUpperCase, right? And you're like, what is that? So what's happening is that toUpperCase also has a type. That type is that it's a function type, right?
Right.
And so what's happening here is that sohappy is a string type, and then we're accessing its toUpperCase method, which is a function type. Now console log gets this function type, and it says, hey, function type, can I convert you into a string type? And the function is obliging and says, okay, when you convert me to a string, the string representation of a function is just the string function space function name, right? So what it's outputting is not actually the function itself, it's the string version of the function, right?
Right.
So we're kind of thinking about all these type operations happening underneath the hood, right? We're getting a type, we're calling a function on it, that function is a type, and then we're converting that function type into a string type. The string methods.
And I was just going to add that on the previous slide that we will see down the road that there are many instances when you would actually want to pass a function into not console log but into other functions, and so there's actually a really good purpose for why it's even allowed.
Yeah.
But to console log, you usually want to pass things that when you convert them to a string, they print out what you expect them to print out.
Yeah, that's a great point. That JavaScript is a very powerful language because it has this ability to work with function types.
Yeah.
All right. So, for example, to lowercase, we can again the string be quiet is a string type. We call the method to lowercase, which is a function type, but we actually call the function with the double parens, and this by calling the function returns to us another string type. Right? So we get be quiet. All the characters are converted to the lowercase version. All right, so to recap, we talked about what a value is. So value, is something that we think of as like the number 5, the string David, the string Nimit, a function. These are individual values. But types represent the thing that value is, right? And so types kind of represent intrinsic properties, or properties of values that are shared amongst all things, all values that have that same type, right? So all strings that are of the type string have certain properties that they share. Same with numbers, same with booleans, and we'll cover other types that are in JavaScript, down the road.
Yeah.
The key to working with types in JavaScript is to use the type of operator, right? So type of is an operator that takes a type as something that a value and returns to you its type as a string type. And then we talked about different things. We talked about number types and the operators that they share. I talked about Boolean types, and I talked about string types and all the methods that come with string type. So okay, that's it for
one thing I wanted to quickly add is that we discussed a bunch of methods that are on each different type. But actually, there are tons and tons of methods. Like we only discussed a few of them, and so if you, for example, Google, JavaScript string methods, you'll find a whole list of cool things that you can do to strings. And when you get more advanced in JavaScript, you'll actually also learn how you can add your own methods to the string prototype. Although it's not necessarily very recommended, but that's one of the reasons JavaScript is very powerful, because it actually lets you, it gives you a lot of power in your hands to really to really build a language in the way that you want.
And the methods that we saw, so like string to uppercase to lowercase, as Nimit mentioned, there's probably, I would say, anywhere from high, like 50 to 200 built-in types on these things, like numbers, strings, and booleans. And we typically refer to that as the standard library of a programming language, right? So you gotta think of like JavaScript itself has its core things, and then it gives you all of these methods that help you work with the different types, right? And the nice thing about programming languages like JavaScript, they give you so many of these built-in methods to work on these types that are really, add a lot of convenience to you, right? So for example, if you didn't have a to uppercase method and you wanted to do the operation, it's very common. Like let's say you're outputting something on a web page and you're saying all headings should be in all character, cap cases, right? If you didn't have this to uppercase, you'd have to write a pretty complex mapping function, right? You're saying the function would look underneath the hood like, is this character uppercase or lowercase? If not, find the uppercase version of it, right? And that's not trivial.
And you'd also have to differentiate between which things can be uppercased, which things can't be uppercased.
Yeah. And so as we're working, knowing these methods is a part of becoming a powerful programmer, is understanding what the language really helps you do right out of the box.
Yeah. And, but however, we wouldn't recommend spending too much time like just memorizing methods, because the because it's so easy to look them up.
Yeah.
It's so easy to look them up, and as you work with JavaScript more and more, a lot of them will, you just get to know a lot of methods that
Even the
that
key
you need.
ones. And I think beginners oftentimes worry a lot about how many do I need to know? Do I need to memorize all
Yeah.
these? And I would say there's probably like 5 to 10 core ones for each type.
Yeah.
So like in string, getting characters, reversing the string, sorting the string.
Even
These are
things like dot length, which is not a method, but it's a property that you
Yeah.
need to use a lot. That's available on strings.
So I think definitely programming is not a memorization game. You probably have to only ever know 5. And then over time, you'll develop an intuition of, should this thing be in the standard library? I think something like this might be in there, and you can look it up, but you don't have to memorize it. So don't even feel like in this lecture, you have to memorize those methods we talked about. We're just trying to show you, different types, the methods that they come with, and that methods, operators can, either return something of the same type, like 10 plus 5, or return something of a different type, like 10 equals 11, that returns a Boolean type.